going to see lesson number 14, substances in common use. Today's lecture is part 1. Myself, Ashok Gadge from Shahjanagar BMC English Secondary School, Chittagong, Trombe. In first part, we will see the important salts which are useful in day-to-day life, such as NaCl, NaHCO3, Na2CO3. In the second part, we will see what do you mean by radioactive substance, what are the uses of radioactive substance, and what do you mean by radioactive isotopes. In the second part, the third part, we will see some chemical substances in day-to-day life. So in first part, we will going to see first what do you mean by salt, what is acid, what is base, what do you mean by acidic, neutral and basic salt. Then detailed format of sodium chloride, formation of sodium chloride, then sodium bicarbonate, that is formation of Na2CO3 and NHCO3, washing soda. Then we will see the difference between carbonates and bicarbonate salts. Then we will see bleaching powder, then formation of bleaching powder, some crystalline salt, what is the difference between soap and detergent, and lastly we will see some question answers. So we will start now. There are 4 basic which are important salts which we use in day-to-day life. First is table salt. The chemical name of table salt is sodium chloride. Chemical formula is NaCl. The second basic and important salt which we use in day-to-day life is sodium bicarbonate. Commonly we called as a baking soda, and the chemical formula is NaHCO3. The third salt is washing soda. Chemical name of washing soda is sodium carbonate, and the chemical formula is Na2CO3. And the fourth one, bleaching powder, chemically it is called as a calcium oxychloride. Chemical formula is CaOCl2. Now we will see what do you mean by salt. Now salts are the ionic compound which do not have H plus and OH minus ions, and that contain only one kind of cation and anion. Those are called as a simple salts. Some examples are there: Na2SO4, K3PO4, and CaCl2. The first example, that is Na2SO4. In this Na2SO4, the formation of Na2SO4 is done by SO4 molecules and 2 Na molecules. The charge on SO4 molecule is -2, and the charge on the sodium molecule is +1. So the 2 molecules are required to fulfill SO4 molecule. K3PO4, here -3 charge on PO4 molecule is fulfilled by +1 charge of 3 potassium ions. And the third example in CaCl2, the +2 charge on calcium is fulfilled by -1 charge of 2 chlorine molecules. Now in this way, the except H plus and OH minus ions, there are cations and anions in the salt. Now, inorganic substances occurred naturally in the form of salts rather than the acidic or the base. About 80 million tons of salt is added every year in a seawater. Therefore, sea is the richest source of salt. In fact, sea is the rich of several salts of various elements like chlorine, sodium, magnesium, potassium, calcium, bromine. However, We also use other salts apart from the day-to-day salts in our day-to-day life. Now, there is a strip which is numbering from 1 to 14. The name of strip is called as a pH paper. And what is the function? It is used to decide whether the given solution is acidic solution or the basic solution. Now, when solution color is between 1 to 6 on pH paper, it is acidic solution. And when solution color is 7 on pH paper, it is neutral solution. And when solution of that color of that solution is 7 to 14, it will considered as the solution is the basic solution. Now, from that, we will decide whether that substance is acid or the base. Now, what do you mean by acid? Acid is the substance which on dissolving in water give rise to H plus ions as only cation. Now, here are some example: HCl, H2SO4, H2CO3. Now, in HCl, H plus ions are raised. In H2SO4, again H plus ions are there. H2CO3, there are H plus ions also. Next, base. A base is the substance which on dissolving in water give rise to OH minus ion as the only anions. Now here example Na2, NaOH, here OH minus ions are there. CaOH twice, here also OH minus ions are there. Now we will talk about salts: acidic salt, neutral salt, and basic salt. Now, a salt is a neutral when its pH is 7. Now, how it is formed? A strong acid reacts with strong base to give neutral salt. Strong acid react with strong base to give neutral salt. Now, a salt is acidic when pH is less than 7. How it is formed? A strong acid react with weak base. Therefore, there is a formation of acidic salt. Now, third is salt is called as a neutral salt. Salt is called as a basic salt when its pH is more than 7. How it is formed? A weak acid react with strong base to give basic salt. Now, first, that is sodium chloride. The first daily used salt is sodium chloride. We will see in detail. Sodium chloride is also called as a table salt, which we use in day-to-day life. It is also called as a table salt or a common salt. It gives salty taste to food. It is the most used salts from other salt. Chemical name is sodium chloride. Sodium chloride is formed by neutralization reaction between sodium hydroxide NaOH and hydrochloric acid HCl. Now it is a neutral salt and the pH value is 7. Now how NaCl is formed? Na molecule, sodium atom, chlorine atom. Sodium atom have electronic configuration. Atomic number is 11. Electronic configuration 281. Valence electron 1. Valence electrons are the electrons in outermost orbit, and the valency combining capacity to form a compound, that is +1. Now in chlorine atom, atomic number is 17. Electronic configuration 287. Valence electron, that is the electron which are present in the outermost orbit, that are 7, and the valency is -1. Okay. Now, when sodium is donating 1 electron, chlorine is accepting that 1 electron. Sodium is donating one electron because it is easy to donate to form the outermost orbit, 8 electrons in the outermost orbit to complete their octet. Now chlorine is taking one electron to complete its outermost orbit with 8 electron according to the octet rule. Now here, when sodium is donating one electron, it is in the form of Na plus ions, sodium ions. Another name is called as a cations. And chlorine is accepting one electron. Therefore, for acceptance, there is a minus charge and there is a formation of chloride ions. Again, it is called as an anion. So here, that sodium ions and chloride ions are formed in aqueous solution of sodium chloride. Now, properties and uses. Common salt is colorless ionic compound. Common salt is crystalline ionic compound. There is no water of crystallization in crystalline structure. It is neutral salt, salty in taste. The compound is used for production of salts like Na2CO3 and NaHCO3. Now, when the electric current is passed through the saturated solution of sodium chloride, the saturated solution of sodium chloride is called as a brine. It is electrolyzed. Now, in this process, saturated brine, the hydrogen gas is released as cathode and chlorine gas is released at N. Now, this method is used for production of chlorine gas. In this method, important basic compound, that is NaOH, is formed in the cell. When salt is heated at high temperature, about 800 degrees Celsius, it melts, and this state is called as the fused state of salt. Now, when fused state is electrolyzed, the chlorine gas is released on anode and the liquid sodium metal at cathode. Now, just we have discussed the saturated brine. 25% of aqueous solution of salt is called as a saturated brine. When 1/5 of the solution is evaporated, the dissolved salt get crystallized and the salt gets separated from the solution. Now next, sodium bicarbonate. The common name is called as a baking soda. Chemical name is sodium bicarbonate and the chemical formula is NaHCO3. Now, your mother brings cake on your birthday or make it at home. Also, she makes bhaji for you. Have you ever asked your mother what makes the cake porous or the bhaji crispy? The mother adds in that batter, that is the baking soda. Now, this baking soda is white non-crystalline powder. Its chemical name is sodium hydrogen carbonate, or we can say sodium bicarbonate. Its molecular formula is NaHCO3. Now, how this Na2CO3 and NaHCO3 is formed? Carbonates CO3 and bicarbonate HCO3 are acidic radicals. Now, negative charge on any radical represents its acidic nature, or we can say the acidic nature is represented by the negative charge. This negative charge is fulfilled by same number of positive charge. For example, carbonate has -1 charge, which is fulfilled by sodium with +1 charge to get sodium carbonate. And this negative charge is fulfilled by number of positive charge and the number of atoms So here, for example, carbonate has -1 charge fulfilled by hydrogen +1 charge and sodium with +1 charge to get sodium bicarbonate in the second one. Now, properties and uses. NaHCO3 react with moist litmus paper, red litmus paper, which means it is the basic solution. Now, it is used to make bread, cake, dokla. Being basic in nature, it is used to reduce acidity in stomach. So everyone knows about this baking soda. NaHCO3 is used to make active substance CO2 in the fire extinguisher. Baking soda is used to clean oven also. Now next, that is washing soda. Chemical name, chemical formula is Na2CO3 dot H2O. First, there is a one activity procedure is there. Take sample of water from well or the bore well in a beaker, add some soap and stir it. Then take another sample, add some spoonful of washing soda, stir the solution, add some soap and stir it again. So in the first solution, there is no washing soda, only soap was there. In the second solution, there is a soap and washing soda. We have to observe that and find out what is the difference, what is the change in occurs in both the solution, why this change is occurring, and what we understand from that. We will see. The hard water from the well or the bore well becomes soft on adding washing soda. That is the concluding point. The hardness of water is due to presence of chlorides, sulfates of calcium and magnesium in that water. Now Na2CO3 is added to it to soften such water and make it suitable for use. The reaction with Na2CO3 causes the formation of insoluble carbonates, salt of magnesium and calcium. Now, sodium carbonate is water soluble salt of sodium. Crystalline sodium carbonate on keeping loses its water of crystallization readily, and white powder is obtained. Now, this powder is called as a washing soda. What are the properties and use? Washing soda is whitish, odorless powder at room temperature. Litmus has blue color in its aqueous solution. It is hygroscopic, that it absorbs the moisture if it is left exposed to air. Now it is used mainly for washing clothes. Sodium carbonate is used in the glass and paper industry also for refining of petrol. Now write down the reaction of Na2CO3 with H2SO4. Here is the reaction. Na2CO3 plus H2SO4 gives Na2SO4 plus carbon dioxide and water. So here sodium carbonate react with sulfuric acid to give sodium sulfate, carbon dioxide and water. Now, what is the difference between carbonate and bicarbonate? So the carbonate has -2 electrical charge and bicarbonate have -1 electric charge. Both have minus charge, that is acidic radicals. These are the acidic radicals. Now, carbonate and bicarbonate both are the forms of carbonic acid. The molecular formula of carbonic acid is H2CO3. When one hydrogen molecule is donated, there is a formation of bicarbonate ion, that is HCO3. And again, if one hydrogen is removed, there is a formation of carbonate ion. So CO2, CO3 -2 charge. So that much is difference between carbonate and bicarbonate. Now we are moving to the next concept, that is bleaching powder. Everyone knows about bleaching powder. All the cosmetics have bleaching powder. Chemical name is calcium oxychloride, CaOCl2. Now take a piece of colored cloth, put some saturated solution of bleaching powder on small part of it and observe what change takes place in the color of cloth. Answer: the color of cloth disappears due to bleaching powder. Tap water has typical strong odor in the rainy season. Now, have you experienced it? Even water in the swimming pool also has the same odor. Now, the smell or the odor is of chlorine gas, which is used to destroy microbes in the water. So chlorine gas is strong oxidizing agent. It has strong disinfecting as well as bleaching action. Chlorine is inconvenient to handle because of its gaseous state. Instead, the solid bleaching powder is more convenient for use. Now, bleaching powder has the same effect as the chlorine gas, and bleaching powder undergoes slow decomposition due to the carbon dioxide in the air and the chlorine gas is released. Now, bleaching powder gets its property because of this release of chlorine gas. CaOCl2 plus carbon dioxide gives CaCO3 plus Cl2 evolved. Now, how the formation of bleaching powder occurs? One of the famous plant, that is Hasenclever plant, is there. In this plant, it is for not it is not for 9th standard, but bleaching powder formation is very much important for us. Slake lime is used for production of bleaching powder. Slake lime is put in the upper part. From here, these are the rods which are moving, and from this point chlorine is added. Now this chlorine is going in the upward direction. Slake lime is coming in the downward direction. Now here there will be reaction between slake lime with chlorine gas to form a bleaching powder. So at last there is a formation of bleaching powder from the reaction between the slake lime and chlorine gas. Now we will see some properties and uses of bleaching powder. It is yellowish white colored solid substance. Chemical name is calcium oxychloride. It has a strong odor of chlorine gas. It is used for disinfection of drinking water at the waterworks and the water in the swimming pool. It is used for bleaching of clothes also, disinfection of roadside and garbage sites. Dilute sulfuric acid and dilute hydrochloric acid react rapidly with bleaching powder to release chlorine gas completely. So calcium oxychloride also reacts slowly with carbon dioxide to form calcium carbonate and chlorine. Now we will move on to the next concept, that is some crystalline salts. Some crystalline salt. What do you mean by water of crystallization? Here is the definition. Water of crystallization means having a fixed number of molecules present in one formula of a unit of salt. Now, some substances in our day-to-day life use which contain water of crystallization. First is alum. Chemical formula K2SO4 dot Al2SO4 thrice dot 24H2O. Though 24H2O, that 24 number is representing the water molecules in alum, or we can say potash alum. That 24 number is particular for water molecules, and that is called as the water of crystallization. In borax, it is 10, Epsom salt, it is 7, barium chloride, it is 2, sodium sulfate, that is Glauber salt, it is 10. Now, what will be the water of crystallization? For this chart, blue vitriol 5, Epsom salt 7, gypsum it is 2, green vitriol 7, white vitriol also 7. There are n number of examples of water of crystallization. You can search, or you can take screenshot and write down those water of crystallization, so and show it to your subject teacher whether you understood that concept or not. Now we will move on to the properties and uses. First property, alum is used in the process of water purification. Every day in rainy season, we have alum with us. The dissolved substances which are settled down by application of this alum. Because of property of coagulation, the solid impurities in the water come together, become heavy and settle at the bottom. Now, as a result, the water above becomes clear. Blue vitriol is used in the blood test for diagnosing anemia. In the borax mixture, which is used for fungicide on fruits like grapes, muskmelon, slake lime is used. It is slake lime. It is used with a blue vitriol also. Now we are talking about soap and detergent. When oil or animal fat is boiled with an aqueous solution of sodium or potassium hydroxide, sodium or potassium salts of carboxylic acid, that is fatty acid, are formed. These salts are called as a soap. Now, when soap is mixed with a hard water, calcium and magnesium salts of fatty acid are formed, and these bring water insoluble. They form a precipitate, and that is why lather is not formed. Now, what do you mean by detergent? Detergent is a surfactant or the mixture of surfactant with cleansing properties when in dilute solution. So, what will be the difference between soap and detergent? Now, soap are the natural ingredients such as plant oil, coconut oil, vegetable oil, palm oil, pine oil, or the acids derived from animal fat. And the detergents are the synthetic man-made derivatives, which synthetic man-made derivatives. Now, we will see the detailed difference between soap and detergent. The first, that is soap, are formed from natural ingredient. Detergent are formed from man-made or synthetic derivatives. The sodium or potassium salts of carboxylic acid are called as a soap, whether sodium or potassium salts of long alkyl chain that terminate with sulfonate group is called as a detergent. Soap will leave a film. Detergent are free rinsing. Hard water is enemy of soap. Soap can't work in hard water. Detergent can work in any level of hardness of water. Commercial soap production utilizes expensive natural resources like vegetable oil. Detergent typically consume fewer natural resources in the manufacturing process. Now, we will see the difference between both the soaps, bathing soap and washing soap. Now, bathing soap, the high grade fats and oils are used as a raw material. In washing soap, low grade fats and oils are used. In bathing soap, expensive perfumes are used. In washing soap, cheap perfumes are used. In bathing soap, they are potassium salt of long chain fatty acid. Washing soap, these are sodium salts of long chain fatty acid. Bathing soap are usually soft in nature. Washing soap is usually hard in nature. Bathing soap free from alkali, which ensures there will be no injury to skin. Washing soap, it contains some residual alkali, therefore there might be injury to skin. So we will start with the question answer. First question, the number of molecules of water of crystallization in washing soda is 10. Now, water of crystallization, molecular formula of water of crystallization is Na2CO3.10H2O. Water of crystallization in washing soda will be 10. The chemical name of baking soda is, sodium bicarbonate. Next, match the pairs A and B. Saturated brine, fused salt, CaOCl2, NaHCO3, and here the answer. Saturated brine, that is crystallization of salt. Fused salt, that is sodium metal freed. And CaOCl2, oxidation of color. NaHCO3, basic salt. Now, bleaching powder has odor of chlorine. That is give reason. Many times you have to understand first that give reason and then you can write it as you can. Now, bleaching powder has odor of chlorine. So, bleaching powder has a molecular formula CaOCl2. Chlorine is the main constituent of bleaching powder. Slow decomposition of bleaching powder due to carbon dioxide in air, which releases chlorine. Therefore, bleaching powder has odor of chlorine. Now, next, hard water of the well becomes soft on adding washing soda to it. Now, hardness of well water is due to presence of chloride, sulfates of calcium and magnesium in it. To make soft water, washing soda is added. Washing soda react with chloride and sulfates of calcium and magnesium in, and there is a formation of insoluble carbonate salt and of magnesium and calcium, which makes water soft. That is the chemical reaction. MgCl2 plus Na2CO3 gives MgCO3 plus twice NaCl. Now the next give reason, soap forms a precipitate in hard water. Now hardness of water is due to presence of chloride and sulfate of calcium and magnesium in it. When soap is added in a water, displacement of sodium takes place. There is a formation of calcium magnesium salts of fatty acid, and these salts are insoluble in water. They form a precipitate in hard water. Therefore, soap forms a precipitate in hard water. What is meant by water of crystallization? Give examples of salt with water of crystallization and their uses. Water of crystallization definition. The water of crystallization means having a fixed number of molecules present in one formula of unit of salt. Now examples, again alum having 24, borax 10, Epsom salt 7, barium chloride 2, sodium sulfate, that is 10, water of crystallization. Now, uses of it: alum, which is used in medicines, paper industry, bleeding को stop करने के लिए, use in process of water purification. Borax, we use in cosmetic shampoos, old cold creams, remove stains on the cloth. Lab, in lab, for as a basic element from colored salt are determined. Epsom salt for manufacturing fertilizers, enhance green color in the plants and vegetables. Barium chloride, purification of brine, wastewater management. Again, paper industry, dye industry, ceramic, oil purification, and pesticide. Sodium sulfate, usually used in a detergent preparation, paper pulp making, dye industry, and mild purgatives are used. Now, write briefly about three methods of electrolysis of sodium chloride. The first, sodium chloride, is a dilute solution of sodium chloride. Second, sodium chloride is saturated solution of sodium chloride. And the third, sodium chloride is fused sodium chloride, fused solution of sodium chloride. Now we will see the method of electrolysis in first, sodium chloride. When electric current is passed, the solution is electrolyzed and a hydrogen gas is liberated at anode, and oxygen is liberated at cathode. In the saturated solution of sodium chloride, electric current is passed, solution is electrolyzed, hydrogen is liberated at anode, chlorine is liberated at cathode. In fused solution of sodium chloride, electric current is passed, solution is electrolyzed, chlorine is liberated at anode, and liquid sodium is deposited at cathode. Now, write down the chemical formula of bleaching powder, common salt, baking soda, washing soda. Number 1, bleaching powder CaOCl2, common salt NaCl, and baking soda NaHCO3, washing soda Na2CO. Thank you. Sir, it's done.
Hello, sir.